I'm Yuki. Welcome back to the IoT Programming course. This course is based on the book IoT Programming with MaTouch ESP32S3 1.28 touch. The goal of this course is to help you quickly learn the MaTouch 1.28 touchless controllers, from basic uses to IoT applications. In our last lesson, we displayed Hello World on the screen. Today, we are going to learn about the other two interfaces on the screen, touch and encoder. For the touch interface, the MaTouch 1.28 touchless controller uses a capacitive touch interface driven by the CST816S via I5C protocol. So what is I5C? I5C is a widely used two-wire series communications interface. It uses SCL and SDA to exchange data between the ESP32 and the touch controller. I5C allows multiple devices to share the same bus, each identified by a unique address. For CST's 816S, this is typically 00S15. So how does capacitance touch work? When a figure approaches the screen surface, it changes the locate capacitance values. The CST's 816S chase continuously scan the screens, detect these changes, and report the SY coordinates of the touch positions back to the ESP32 through I5C. For the encoder interface, it typically has three terminals A, B, and C. Terminals A and B's output digital passes as the shaft rotates, and their relative phase determines the direction of rotations. Terminals C as common G and D. When the node is turned clockwise, pin A is grounded before pin B. When the node is rotated counterclockwise, pin B is grounded before pin A. By monitoring when each pin is connecting or disconnecting from the ground, we can determine the direction in which the node rotates. This can be accomplished simply by observing the state of B when the state of A changes. If B does not equal A, the node rotates clockwise. If B equals A, the node rotates counterclockwise. Now, let's open the touch and encoder code and see how it is implemented in the program. By scanning the QR codes in the book, you can download all the example codes used in this course and send them to your computer. Open the file touch and encoder. Define the touch and encoder pin. Define encoder code, stature, and flag. Screen refresh flash and touch coordinate. In the setup function, initialize the pin, and we can see that the screen backlight, the encoder pins, and the interrupt are initialized. When the encoder CLK level changes, the program will enter the encoder IRQ function. In the encoder IRQ function, the state of the encoder's CLK and DT pins are changed to determine the rotation direction. When an interrupt occurs, the encoder's mode phase is set to 1. Then, back in the setup function, we initialize the I5C, which is used for the touch pins. In the root function, we check whether the screen has been touched or the encoder has been rotated. If so, we set the screen refresh flash to 1 in order to update the page. The page function manually handles refreshing the encoder code and the touch coordinate. With that, the code portion is complete. Use Type-C USB cable to connect the board and PCs. And click the touch menus. Then select ESP32S3 test model under board. Choose the connect point and set USB CDCs on both to enable. Click the Upload button in the Arduino IDE and wait for the code to upload. As download is complete, you will see the screen showing the coordinates and encoder data. Congratulations on completing Lesson 2. See you next time. Bye.